everyone, it's Zaina Zaytoun. So this video will be on the second part of integration for grade 12. So if you didn't see the first part on definite integrals, you should check it now. The objectives of this video is to solve integrals using change of variable method. Students watching this video should know definite integrals, it's explained in the previous video, exponential and logarithmic functions, and integration by change of variable taken in grade 11. Now, as I said in the previous video, I won't be including integrals for trigonometric functions in these PowerPoints. I'll do a separate video just on trigonometric functions. And in this video, I only included integrals for logarithmic and exponential functions. And also I didn't include the integrals that are taken in grade 11. So in order to review them, you should watch the video for grade 11 on my channel. So go to my channel and then to my playlists. You'll find grade 11 and then you'll find these videos on integrals. You should watch this one on change of variable where I explained the method, and I also solved integrals of rational, irrational, polynomials and their composition because I won't repeat them in this video. So let's start. Integral of the function of the form e to the power ax plus b. Before I start, recall that the integral of e power x is e power x plus c. So now how can you integrate e power ax plus b? Since it's not a basic integration, then you need change of variable. So what would be your substitution? Remember that in order to choose a substitution that will work, then it's the derivative of this substitution, so du, should also be found in this integral such that you can rewrite the whole integral in terms of u and du. And also, as I said in the video for grade 11 on change of variable that I asked you to watch before this, the substitution is usually the power or the function under the radical or the function in the denominator. But I'm not saying that this works on all types of integrals, but it works on many types of integrals. So let's start by this one. So I'll take the substitution to be the power, so ax plus b, and I'll try if it works. So let u equal ax plus b, then du would be the derivative. So the derivative of ax is a, and this will be 0 because a and b are constants. And don't forget the dx. So du is equal to a dx. So in order to see if this works, then we need to see if this can be rewritten in terms of u and du. So this will be e power u, because this is the substitution u. And what's left is only dx. So we look back at du and see if we can rewrite it in terms of du. So you see that it differs only by a multiplication of a constant, which is a. And also I said in that video, if du differs by a multiplication of constant, then it also works. So we only need to add a here. But in order to be able to multiply by a, we should divide by a. So we will get 1 over a integral of a e ax plus b. Now the second step is to rewrite the integral in terms of u. So the substitution is ax plus b, so this becomes u, so it's e power u. And what's left, which is a dx, is du. So we get 1 over a integral of eu du. Now we need to integrate this. This is very simple. The integral of e power u du is e power u. So we get 1 over a e power u plus c. Now don't forget to do the last step when you need to replace u back in terms of x. So you should write ax plus b. So it's 1 over a e power ax plus b plus c. So this is a general rule that you can always use. So we can conclude that the integral of e power ax plus b is equal to 1 over a, where a is the number multiplied by x, so it's the coefficient of x, e power ax plus b plus c. So let's do an application. This is the rule. Now the integral of e3x plus 5 is, since it's in the form e power ax plus b, then the answer would be 1 over 3 e power 3x plus 5 plus c. Since here the coefficient of x is 3. Let's do another example. Do this example by yourself. So what's a here? What's the coefficient of x? It's minus 2. So it's minus half, since 1 over minus 2 is minus half, e power minus 2x plus 1 plus c. What about this integral? Is it of the form e power ax plus b? Yes, since a is minus 1, which is the coefficient of x, and b is just 0. So whenever the power of the exponential function is of first degree, then you can apply this rule. So here a is minus 1, so you will get 1 over minus 1, which is minus 1, and the exponential function e power minus x, and of course plus c. Same here, e power x minus 7. So this is a first degree polynomial, so we can apply this rule. What's a in this case? It's 1, since the coefficient of x is 1, so it'll be 1 over 1, which is 1. So it'll just be e power x minus 7 plus c. Now the integral of the function of the form 1 over ax plus b. So also before I start, I want you to recall that the integral of 1 over x is equal to ln x plus c. But here it's not 1 over x, it's 1 over ax plus b. For this one, I'll give the rule directly because the proof is very similar to the previous one that we just did. So the integral of this form is 1 over a ln ax plus b. So you can prove it using change of variable, which is similar to the exponential one, or you can just find the derivative of this function and it should give you this one. So the derivative of this, of ln ax plus b, is u prime over u. So you will get a, which is the derivative of ax plus b, over ax plus b, and then the a in the numerator will cancel out with the a in the denominator, and you'll get this answer. So for example, if you have the integral of 1 over 2x minus 7, so you apply this rule, a is the coefficient of x, which is 2, so it'll be 1 over 2 ln 2x minus 7 plus c. Now try to do this one by yourself. So in this one, a is minus 6. So you will get 1 over minus 6 using this rule. So minus 1 over 6 ln minus 6x plus 1 plus c. Now calculate the following integrals. The integral of ln x over x dx. Is this a basic integral? Of course not. So you need to use change of variable method. So you need to try the substitution. Let's try all the possible cases. Let's try x, for example. If u is equal to x, then du would be equal to 1 dx. So how can you rewrite ln x in terms of u and du? This means that this substitution won't work. Think about other substitution. So what about u equal ln x? Let's try this substitution. If u is equal to ln x, then du, the derivative of u, is equal to 1 over x dx, which is found in this integral, 1 over x dx. And we will be able to rewrite these integrals in terms of u and du. So this would be u, and 1 over x dx is du. So it works. So it will become u instead of ln x, and instead of 1x dx du. So this is a very simple integral. It's u squared over 2 plus c. And now don't forget the last step to replace u by its substitution, which is ln x. So you'll get ln squared x over 2 plus c. By the way, this integral is very common. So you see it a lot in the official exams. Now another integral, try to do it by yourself. So the integral of ln squared x over x dx. So it's very close to the one before, except that you have here ln squared instead of ln x. So also the substitution u equal to x won't work for the same reason that I said in the previous integral. Then you have either ln squared x or only ln x. So since this is ln x all squared, so you can take the function under the power. If we took u to be ln squared x, then the derivative of ln squared x would be 2 ln x over x. And if you try to rewrite it in terms of u and du, it won't work. So let's try. So the only option now is ln x. And as I said at the beginning of this video, it's usually the function under the power, so we usually don't take the function with its power. So u is equal ln x, du would be 1 over x dx, which is also found in this integral. Now to check if this substitution is correct, you need to check if you can rewrite this in terms of u and du. So what's u? So u is ln x, so this will be u squared. Let's see what's left. What's left is 1 over x dx, which is du. So this means that it works. So as I said, this would be u squared, and what's left is du. Now this integral is also very easy. It's u power 3 over 3. You add 1 to the power, and you divide by the new power, plus c. And again, don't forget the last step where you need to replace u by its substitution, which is ln x. So you get ln cubed x over 3 plus c. Also another integral. I really advise you to try to do them by yourself, so pause the video, solve them, then check your answers. Also here, what our substitution can be, it can be x, the derivative would be 1 dx, so we won't be able to write 1 plus ln x in terms of u or du. Let's also try 1 over x, u to be 1 over x, then du would be minus 1 over x squared, which is not even found in the integral, so it also won't work. So the only option now we have is 1 plus ln x, so this function. Let's try it. So if u is 1 plus ln x, then du would be, this will be 0, and this will be 1 over x dx, which is found in the integral, and you will be able to rewrite it in terms of u and du. So 1 over x dx is du, and 1 plus ln x is u. So you get 1 over u, and for the rest is only du. Now the integral of 1 over u du, or 1 over x dx, is ln x, right? So this would be ln u. And now we still have the last step when we need to replace u by 1 plus ln x. So it's ln into 1 plus ln x plus c. So notice that when we have logarithmic function, we're usually taking the substitution that includes ln x. But I'm not saying that it works in all integrals, but it's very common. Now the integral of x, e power x squared minus 2 dx. So try all the substitutions and see which one works. So pause the video and take your time. So for me, I'll start by trying u to be x squared minus 2 because I said it's usually the function in the power. And also this is the case in many exponential functions where you take the substitution to be the power of the exponential function. So let's say try u equal x squared minus 2, then du would be 2x dx. Let's see if it works. So since this is u, so this would be e power u. Now we see what's left, which is x dx, and we look back at du. Is it the same x dx? But here you have 2x dx. And also, as I said, if du only differs by a multiplication of constant, then it works. Because you can multiply this by 2 to get 2x, like here, and simply divide by 2 outside the integral. So it'll be 1 over 2, 2x e power x squared minus 2. Now, we rewrite it in terms of u. So e power x squared minus 2 is e power u, and what's left, which is 2x dx, is just du. Now, since the integral of e power x dx is ex, then the integral of e power u du is just e power u. So you get this answer, and then we replace u by x squared minus 2. Also another example, you really need to try them by yourself. So radical x, e power x radical x. So again, I'll start by the power because it works in most of the cases. Let's try u equal x radical x. Now I need to find the derivative, which is du. So you can view this as u dot v and you apply the rule, or you make it as 1 power, as x with 1 power. So this is x times x power half. and then you add the powers, so 1 plus half, you get 3 over 2. Now you find the derivative, so you multiply by the power, which is 3 over 2, and you subtract 1 from the power, so you get half, and then x power half can be rewritten as radical x. Let's see if it works. So this would be e power u, and now we see what's left, which is radical x dx, and we look back at du. Is it the same, radical x dx? Yes, but it differs by a multiplication of constant, so it works. We need 3 over 2 here, so we divide by 3 over 2 outside, so it's 1 over 3 over 2 outside, which is 2 over 3. So we get 2 over 3 outside and 3 over 2 inside. Now, this becomes e power u, and 3 over 2 radical x dx is just du. The integral of this again is e power u, and then you replace u by x radical x, so you get this answer. Now you have the integral of e power x over 1 minus e power x. Actually, this integral is pretty common, so please pause the video and try several substitutions until it works. So let's say try the substitution e power x. Usually, I told you the substitution would be the function in the denominator, but it's not always the case. Let's say start by e power x, then du would be also e power x dx. So this can be rewritten as 1 minus u, and what's left, which is ex dx, is just du. So you'll get 1 over 1 minus u du, and this will give you minus ln 1 minus u if you solved it, which works. But I prefer another substitution. I'll try to take the function in the denominator, which is 1 minus e power x. Then du would be minus e power x, since this is 0. Let's try if it works. So this would be u, and what's left, which is x dx, is roughly du. It only differs by a negative sign, so we can just multiply by a negative here and negative outside the integral. So always try to take the constant which is added or subtracted with the substitution, because it will just be 0 when finding the derivative. So here we multiplied by a negative inside and outside the integral. Now this is u, and what's left is just du. The integral of 1 over u is ln u, and you have the negative here. Then you replace u by 1 minus e power x, and you're done. Now this is the last integral. It consists of both logarithmic and exponential functions. You can see that it's definite integral, so it has boundaries. Now just forget about the boundaries and solve it as the one we solved before. So you need to think about the substitution here. So let's try u to be ln x, because it works on many integrals. So if u is ln x, then du would be 1 over x dx, which is not even found in the integral, so it doesn't work. Let's try u to be the power of the exponential, which also works in many cases. So let's try u to be x minus x ln x. Let's see its derivative, du. So the derivative of x is 1. Now the derivative of x ln x, you can view it as u dot v, then it will be u prime v plus uv prime. So you get this, and then simplify, you'll get 1 minus ln x minus 1, which is ln x, which is found in the integral. So this would be e power u, and ln x dx would just be du. So it works. So as I said, it's e power u du, and the integral of e power u is just eu, and then instead of u we put x minus x ln x. But remember here that you evaluated the indefinite integral, which is without the boundaries. Now to evaluate the definite integral with these boundaries, so remember from the previous video on definite integrals that you need an antiderivative for this, which is e power x minus x ln x, and we ignore the c. And then we put these brackets with the boundaries 1 and e. What does that mean? We need to evaluate it first at e, then minus this antiderivative evaluated at 1. So we replace x by e, so you get e power e minus e ln e, minus we evaluate this antiderivative at 1, and you simplify it. This will give you e minus e, since ln e is 1, So it's e power 0, which is 1. And ln 1 is 0, so you're left with e power 1, which is e. And you're done.